Okay, so we're on the second year Stats and Mechanics textbook, and we're on chapter 6, which is projectiles, and we're looking at exercise 6D, which is on projectile formulae. Okay, so on question 4, it's a problem-solving one, so it's going to be a bit to think about. This one's quite an unusual one, I think, having skim-read it. So a firework is launched vertically with a speed of v. So if it says that, it basically means it's being launched straight up. So with an initial speed of v. So that's annoying because they've used v for the initial velocity, but we'll deal with that. When it reaches its maximum height, it explodes into 2 parts, and they're each projected horizontally in opposite directions. Okay, so let's think about when it's going to reach its maximum height. So let's start thinking vertically for the period before it explodes into 2 parts. Right, so if I take up as positive, its initial velocity we're calling v. Acceleration is going to be due to gravity, and if I'm taking up as positive, that's going to be minus g. I think I definitely want to know how long it takes to reach its maximum height. So let's call that t. And well, when is it going to be at its maximum height? Well, basically, so this firework's getting projected up into the air, so it's going to go straight up, straight up, straight up, but it's going to be slowing down due to gravity. Then when it reaches its maximum height, when it's stopped moving upwards, it's going to explode off into those 2 horizontal directions. So it's going to be at its maximum height when its vertical velocity is 0. So I'm going to use v equals u plus at. I might also need to know its maximum height, as the actual height as well. I'll leave that for now. I don't know if I'll need that. So if I'm using v equals u plus at, so v is 0, u is v, just to keep us on our toes, a is minus g, and t is t, so that would be minus gt. So the time it takes, so if I add the gt over and divide by g, so that's how long it takes to reach its maximum height. Now, if I think about it, if I were to then think, well, what's then going to happen to it? So how long is it going to take to hit the ground? It's going to take the same amount of time to hit the ground as it took to get to its highest point. So if you weren't sure about that, you could work out, sorry, I'm doing V, aren't I? You could work out how high it actually gets. Okay, so you could work out that as well, but I don't think we need that if you're happy that if it takes v over g seconds to get to its maximum point, that's how long it will take to fall back to the ground, because its acceleration is going to be the same. So its acceleration is always just due to gravity. Okay, so that's how long it takes to reach its highest point. So that's then how long it's going to take to hit the ground. We're ignoring air resistance and anything like that. Okay, all right, so then let's think about what's happening after it explodes. So let's do another dodgy picture. Okay, so it's going up and then it's exploding and splitting up and going in opposite horizontal directions. Okay, so now let's start thinking what's going to happen to each of those horizontally. And I don't need to worry about each of them, because so this one is going to fire off to the right, and then gravity is going to bring it down until it hits the ground. And basically I want to know that distance there. Move this up a little bit, can't I? Need to do that. Need to do that. Okay, so that's how far it gets. And then this one, so I can't quite draw it symmetrically, but it's going to go off in that direction. But those will be the same. So if I just work out, if I just look at one of them and figure out how far it travels, then I can just double that to find the distance between them. Okay, so I'm hoping that I can get x is 2v squared over g. That's hopefully what we're going to get. Okay, so horizontally, once it's split, it moves horizontally with a speed of 2v. I know it's going to take v over g seconds until it hits the ground again, because that's what we worked out there. I know acceleration is 0 if I'm looking horizontally, and I'm trying to find sort of how far it gets. So I can acknowledge that a is 0 and use s equals ut plus a half at squared. So I could do that, but horizontally, we don't worry about air resistance or anything. So if acceleration is 0, I can just use that displacement is velocity times time, because velocity is constant if there's no acceleration. So displacement, which I'm going to call x. So x is the velocity, which is 2v times time, which is v over g. So x is 2v squared over g, which is very helpful. That's what I wanted. So I'm just looking at sort of one half of this firework that's gone off to the right. So if one half of it is going to travel 2v squared over g to the right, the other half is going to travel the same distance to the left. So, and I think my diagram is it's not the best, but I think that's clear enough that if someone was marking this, they'd be happy with what I was doing here. So the total distance, which they haven't assigned a letter to, so the total distance will be 2 times that. Do need to be careful though, because obviously that was given to us in the question. So we do need to be careful that we definitely have justified it. I think we're all right. As required. Job done.